Okay, to graph a linear inequality like this one, or to graph the solution set to it, we start out by graphing the line you get when you replace the inequality with an equal sign. And to graph that line, we simply need 2 points on it, so we'll make a little xy table here to find 2 points that are on this line. And it's very nice often to plug in zeros if you can. If x is 0, then this whole first term vanishes, and it's negative 5 times what equals positive 15. Well, negative 5 times negative 3 will be a positive 15. We could also plug in a 0 for y and see what x must equal. 3 times 5 is 15, so if y is 0, x must be 5. And we found our y-intercept and our x-intercept. Notice that x equals 0 when you have your y-intercept and y equals 0 when you have your x-intercept. So let's graph that line. Here's the x-axis and the y-axis. And we have the point 0, negative 3, so negative 1, negative 2, negative 3. There's the y-intercept. The x-intercept is at 5, so I'll make this 1, 2, 3, 4, and extend this a little bit, make this one 5. So we have our x-intercept and our y-intercept. And the line goes through those 2 points. This time it'll be a dashed line, not a solid line, because it doesn't include the line, or equals to is not part of this. So a dashed line through these 2 points. And now we have to decide which side of the line to shade. And as is usual, unless the line goes through the origin, we can always check out the origin, which is especially nice to check because zeros are so easy to substitute. So we decide if this is shaded or not, the origin, by taking the original inequality and substituting 0 into x and 0 into y, and seeing if it does indeed add up to something bigger than 15. Well, in this case it adds up to 0, because 3 times 0 is 0, negative 5 times 0 is 0. And we're asking the question then, is 0 bigger than 15? And the answer to that is clearly no, a resounding no. And that's the answer to our question. Is the origin shaded? No. Well, if the origin isn't on the shady side of the line, there's only one other side, and that must be the shady side. So the solution set to our linear inequality consists of all the points on the downside of this line.